Hey guys, it's late. I made a mistake on my first go around of doing the notes, and I don't have a second one. So we're making the best of it. This is how we roll. So today, you've already done our experiment of looking at perimeter ratio, similarity ratio, and area ratio. Hopefully what you saw was that my perimeter ratio and my similarity ratio are always the same. And then I'm going to square those to find my area ratio. So if my similarity ratio is A over B, then that means my perimeter ratio is the same. And my area ratio is A squared over B squared. You're going to take a second and write those down. Then what we're going to look at next is we are going to find the missing ratios. The first one, fairly easy for us. It gives us our similarity ratio. Now we know our similarity ratio and our perimeter ratio are the same. So that's nice and easy. And we know how to find our area ratio because we're going to square our perimeter ratio. So we are doing that. And we square 3 to get 9. We square 4 to get 16. Now there are 2 more on your notes, and I want you to take those and I want you to fill in the rest of that. We're going to push pause on this video, and then when we come back, you're going to check your answers against mine. If you have questions, I promise you there's someone in the class who can help explain to you how they got the answers that they got. Okay, so now you're going to check your answers against mine, noticing that our similarity ratio is the same as our perimeter ratio, and our area ratio is the perimeter squared. So the next thing we're going to look at is it says if we know the area of 1 or 2 similar polygons, then we can use a proportion to find the other area. And we're going to find the missing measures. So remember that we can either use our perimeter ratio or our similarity ratio or our area ratio. So that's what we're going to look at. Again, I made a mistake up here. That's how I'm rolling right now. One of the things I do want to point out is if we are looking at area and we're looking at the units that go with it, frequently it's inches squared, feet squared, meters squared, centimeters squared. Notice those are squared and our area ratio is also squared. So hopefully that helps you figure out what you're doing, that you need to square our ratio. So the first thing we have to do is we are going to have to find our similarity ratio or our area ratio. We're going to find both. Here, I have to find my similarity ratio of my rectangle. That similarity ratio, hopefully you see, is 3 over 7. Now, I need to find both my perimeter and my area. Remember, my perimeter area or my perimeter ratio is the same as my similarity. So 3 over 7 is equal to, and then I'm going to put my perimeter. I don't have the perimeter for the small one, so that means I have to put a variable there, an x. I do have a perimeter for the large one, so that is 42. Now, I am going to assume that you guys can do that cross multiplication. You are going to cross multiply. So 3 times 42 is equal to 7x. And then you're going to divide by 7 so that we know that x is equal to 18. We have 18 units. Now remember, we're always going to put our units at the end. Then we now have to find area. I can't use this ratio because just like up here, when we did this, I can't use my similarity ratio. I have to use my area ratio. So I'm squaring both of those so that I have 9 over 49. That's my new ratio. So just like before, when we're putting something into a proportion, we just need to find the ratio, and then it helps us find the actual value. Is equal to 36. Notice 36 goes with my small rectangle. So 36 has to be on top with my 9 over x. So we're going to cross multiply so that I have 49 times 36 is equal to 9x. And then I'm going to divide. I have done this on my calculator ahead of time, so I don't know 49 times 36 because I don't have one of my fancy calculators at home. I have my little 30. So 49 times 36 divided by 9x is equal to 196. 196, and that is square units. Oops. So let's look at this to make sure that that makes sense. That this is 42, we need our perimeter to be significantly larger than that. And so that would make sense. All right, next one is a triangle. Again, we are always finding one of our ratios, similarity, perimeter, or area. Today, for this, I just need my perimeter. Perimeter is the same as similarity. So I'm going to put 8 over 24 is equal to the 60 is in the same, goes with my 24. So I'm going to cross multiply so that I get 8 times 60 is equal to 24x. I'm putting that into my itty bitty calculator because I did not do that one earlier. You also are putting that into your calculator. And I got that x is equal to 20. So this is 20 units. Let's check and make sure that it makes sense that this one is 3 times as large as this one. That does make sense. Fantastic. All right, flip the page. Okay. So the next three, or the next two, don't give us anything to be able to make our ratios. So we can't do them. That's okay. We've got some word problems. Those will be helpful. All right. This says the areas of two similar triangles are 50 square feet and 98 square feet. What is their similarity ratio? What is the ratio of the perimeters? So we've got a couple things we have to break down. We first are given the areas of two similar triangles. So we can write an area ratio, where my area ratio is 50 over 98. Hopefully everybody's good with writing that ratio. Now, the next thing that it's asking for is the similarity ratio. To go from the area ratio to the similarity ratio, we are going to have to take the square root of both of these. So when we look at, so we are going to break this down. Neither one of these are perfect squares. That's okay. We can figure that part out. No issues. But we are going to have to figure out what perfect square does go into those. So a reminder of our perfect squares, 1, 4, 9, 16, 25, 36, 49, 64, and 81. I think I got them all. When I look at 50, hopefully instantly you could see that 25 could be, 50 can be broken down into the square root of 25 and the square root of 2. So if I'm taking the square root of 50, I can say that it's the square root of 25 times the square root of 2. The square root of 25 is my perfect square. The square root of 2 is not. 98 gets a little more difficult. Hopefully you can see 98 close to 100. So I'm looking at 49 would be a perfect square because that's 40, the square root of 49 times the square root of 2. So the square root of 49 times the square root of 2 is equal to 98. The reason we're taking these square roots is because this is the area ratio and we need to find the similarity ratio. I have to take those square roots. And any monkey can put it into a calculator. You guys are not monkeys. So we are going to find we're going to simplify. The square root of 25 is 5 square roots of 2. And The square root of 49 is 7 square root of 2. Now, those square roots of 2 can cancel out. They're exactly the same. So they're going to cancel so that my perimeter ratio, or I'm sorry, my similarity ratio is 5/7. That is the same as my perimeter ratio. So both similarity and perimeter. So if you are given an area ratio, you are going to need to then take the square root of it, do not divide by 2, the square root, to find our similarity and perimeter ratios. Let's do the next one. The areas of 2 similar triangles are 32 square centimeters and 7 square centimeters. What is the similarity ratio and what is the perimeter ratio? So they are giving us area, which means that our area ratio is 32/72. That's my area ratio. Now I have to find the perimeter or similarity ratio. So in order to do that, I have to take the square root of 32 and 72. Neither one of them are perfect squares. So again, we're going to simplify. We're going to look at our perfect squares up above. Hopefully you can see that 16 times 2 is 32. So I'm going to say that we have the square root of 16 times the square root of 2. 16 times 2 is 32. We have to take the square root of 32 in order to get our similarity ratio. I also have to take the square root of 72, not a perfect square, but 36 times 2 is a perfect square. So I'm taking the square root of 72, which really is the square root of 36 times the square root of 2. Hopefully you can see that that 16 times 2 is 32 and 36 times 2 is 72. So the square root of 16 is 4. We leave the square root of 2. And the square root of 36 is 6. And we leave the square root of 2. Now the square roots of 2 cancel, because I have the same exact thing on top and bottom. They can cancel. So my similarity ratio and my perimeter ratio are 4/6, or because both of them can be divided by 2, 2/3. So keys for today's work are making sure that we know that in order to get our area ratio, we have to square our similarity or perimeter ratio. And if I'm given an area ratio, I have to take the square root of it. We are always going to simplify our radicals. We are not going to just put it into a calculator. You guys have some homework to do. You grabbed some of it on the way in, and then you have 8-6. When I'm looking at 8-6, there's a couple of problems that I want to make sure that we're doing. Actually, as I'm looking at it, I think all of them are important. Last year, a lot of students struggled with this, and I want to make sure that we understand what we're doing. So you are going to do all of 8-6 and all of that sheet that you had. Please remember that we have a test next Friday. So we come back Wednesday, Thursday with a review. So any questions you have, I will go over them Wednesday when we're in class, but you need to have done your best, done productive struggle. And I hope you guys have a fantastic weekend, and I can't wait to see you next week.